Very good morning, friends. We were discussing with synthesis of various heterocyclic compound of drug quality. Today, we are going to discuss the synthesis of a sulfur drug, that is sulfamerazine. This is the structure of sulfamerazine. It has para-aminobenzene sulfonamide group attached to the pyrimidine ring system. It belongs to the class of antibacterial agents containing a sulfonamide group in it. That's why it is a sulfonamide antibacterial agent. It inhibits para-aminobenzoic acid and thus inhibits the tetrahydrofolate reductase enzyme and produces its antibacterial effect. It's a very good antibacterial agent and it is used in treatment of various bacterial infections like bronchitis, prostatitis, and urinary tract infection. To synthesize this molecule, we know that it has a pyrimidine ring system attached to para-aminobenzene sulfonamide group. To synthesize this, the strategy adopted is to synthesize the pyrimidine ring system first and attach the para-aminobenzene sulfonamide group to this pyrimidine ring system. If I analyze the structure, this is one methyl group. I can cut over here and I can add one carbon donor to get this one methyl group. I can cut over here 1, 2, 3 carbon donor. I can take as another synthon and I can cut over here. I'll get N double bond C N NH, a guanidino group which can act as another synthon, a sulfone group and the aniline group. I can cut this into the small pieces and join all those pieces together to get sulfamerazine. I have to choose a 3 carbon donor and a 1 carbon donor and react to get a 4 carbon donor to construct the pyrimidine ring system. I'll take a 1 carbon donor, a ethyl formate and treat with acetone. 1, 2, 3. It is a 3 carbon donor and this is a 1 carbon donor. I make them to react together in the presence of a strong base like sodium ethoxide, OET minus, abstract the proton, leaving the electron pair onto the carbon, which creates a carbene ion. The carbene ion which is created by the abstraction of this proton by this base is unstable. And this, to gain its stability, the excess electrons on this carbene ion, it donates to this carbonyl carbon, which is an electron deficient center, which deficiency is attributed to the electron negativity of the adjacent oxygen attached to it. Already this carbon is tetravalent. One more bond is formed. It becomes unstable. Ethoxy group is an easy leaving group. That's why ethoxy gets kicked off and this will lose as ethanol and I'll get corresponding derivative CH3 CO CH2 CHO. Then this has 1, 2, 3, 4, a 4 carbon donor. I'll treat with a guanidine group. NH2 C double bond NH2 is guanidine. The amino group is in sp3 hybrid form. That's why it's a lone pair of electrons. And this excess lone pair of electrons, it can donate to this electron deficient carbonyl carbon, and it has to maintain its tetravalency. Pi electrons moves on to oxygen. O minus combines with H plus to give OH, and I'll get the molecule in which the bond is found between the nitrogen and carbon, and carbonyl oxygen has converted into alcoholic group. On further heating, it undergo dehydration. The nitrogen-hydrogen bond breaks, and these excess electrons are shared with the adjacent carbon, and the carbon has to maintain its tetravalency, and OH gets kicked off as OH minus. OH minus and this H plus combines together to lose as water molecule. The pi electrons moves towards the nitrogen, creating the electron-rich nitrogen. These excess electrons are donated to the adjacent carbonyl carbon, and the pi electrons moves on to oxygen to maintain its tetravalency, and this O minus combines with H plus and becomes OH. The cyclization has taken place. This undergo aromatization to get its stability. As these electrons are moved towards the nitrogen, this carbon has become positive. That is mentioned over here. The carbon-hydrogen bond breaks, and this excess electrons are shared with the adjacent carbon. And as it has shared these excess electrons, the carbon and oxygen bond breaks. This loses as OH minus, combines with this H plus and loses as water molecule. To satisfy this positive center, the nitrogen-hydrogen bond breaks, and that electrons are utilized to satisfy this positive center, and aromatization has occurred to give 2-amino 4-methyl pyrimidine ring system. We have constructed the 2-amino 4-methyl pyrimidine ring of this sulphamerazine. Now I have to synthesize para-amino benzene sulfonyl group and attach that to this pyrimidine 2-amino 4-methyl pyrimidine ring system to get sulphamerazine. Let us look into that. I'll take acid anilide and treat with sulfonyl chloride. The sulfur being electron deficient, as it is flanked between all the electron withdrawing groups, it acts as an electrophile. In the presence of an electrophile like sulfonyl chloride, there is an electromeric effect, and the pi electrons moves towards a carbon, creating an electron-rich center, and these excess electrons are shared with the electron-deficient sulfur, which has to maintain its valency, and chlorine gets kicked off as HCl. I'll get corresponding acid amido benzene sulfonyl chloride. As NH is ortho-para directing, the para derivative will get in large quantity. This para acid amido benzene sulfonyl chloride I'll treat with 2-amino 4-methyl pyrimidine. The lone pair of electrons on the nitrogen attacks on the electron deficient sulfur to maintain its valency. Chlorine get kicked off, H plus from NH2 and Cl minus from over here combines together to loses HCl, and I'll get corresponding sulfonamide derivative. If I hydrolyze this, the aceto group is removed. I treat with sodium hydroxide. OH minus attacks on the carbonyl carbon, and the bond between the nitrogen and carbon breaks, and it hydrolyzes to give corresponding amine derivative, that is nothing but sulphamerazine. This is how we can construct this sulphamerazine ring system. This has its utility as a good antibacterial agent. Sulfur drugs, though they are the oldest drugs, but even now, this is one of the drugs of choice for the treatment of urinary tract infection. Next class, we can deal with other drug molecules containing the heterocyclic molecule. Till then, have a nice day. Thank you.